All right, everyone. It's quite a pleasure to be here at the BIM Coordinators Summit 2023. It's also a pleasure to contribute into this conference. Today we're going to be talking about BIM implementation for PoE and FMP systems. So our agenda today, we're going to be talking about like what PoE and FMP systems are, BIM goals, the challenges we encountered in that realm, and the solutions we developed in BIM implementation. So what are PoE and FMP systems? PoE stands for Power over Ethernet, which is technology of delivering DC power over Ethernet cables. This technology has been around for quite a while. It might not be mainstream as a lot of other electrical systems. However, using PoE systems have proved to reduce power consumption by around 30%, specifically in lighting use, for example. FMP stands for Fold Managed Power, which is basically to monitor and control power delivery within a facility. So standing at the crossroad between FMP and BIM modeling, in 2022, I had the privilege to work with a company called Sinclair Digital. They specialize in FMP and PoE systems, and I had the opportunity to work with them to build a BIM library for them to be able to contribute into the clash detection and coordination in any project they work on. So their methodology is basically turning a building into a microgrid, and basically taking the power coming from the main city grid that is then transferred into DC or digital electricity that is then distributed throughout the building using PoE systems. So the goal was to build FMP and PoE BIM families to allow Sinclair Digital to contribute into the BIM modeling and into the clash detection and coordination on their projects. However, working with new technologies require more than classical solutions. Why is that? Because Revit has some limitations. So while Revit can support architectural, structural, MEP systems, you can design all these systems, even some fire protection and fire alarm systems, it does not support FMP or PoE systems. Here, for example, this is a collection of the families that we built for Sinclair Digital, this part of the library. However, these families or these elements are standalone elements. Yeah, you can put them in the building, but you cannot do cable routing, you cannot do load calculations, thus your clash detection and coordination is not going to be effective. So the main issues is we wanted to be able to do modeling, to be able to build circuits and networks, be able to do calculation, switch schedules, and routing. And this is when we realized that a Revit plugin would be the solution. So ladies and gentlemen, I introduced to you FMP Plus. FMP Plus is a Revit plugin that would allow PoE and FMP designers and contractors to design FMP, PoE, XPoE, and SPoE systems in the Revit and be able to contribute into the clash detection and coordination. This is a general layout of how the plugin would look like, as you see FMP Plus, and this is how our ribbon would look like. On the right here would be basically your BIM families imported into the plugin, which will allow you to place them within your architectural or your electrical model. In junction, and I'll go back here, if when you use the network layout, which is the very first icon, it will give you something like the two bottom icons where the PoE designer will be able to configure and create the actual network, identifying the exact ports on each switch where certain drivers are connected. What you see up above is the cable routing. So The network will be married to the BIM model that has been created, like you see it in the top of the screen, and they would be able to do their cable routing. So basically, they're doing two things in one. This is a general layout of when you're creating your basically library on the left. So this is on the network side, and this network side is what would be married to your BIM family side. So this is a quick demo showing, this is, for example, like someone creating a new switch and they're configuring it. So they're specifying this in accordance to the manufacturer specs. They're able to identify their ports, create as many ports as they need. In this example, we have a 12-port network switch. You can also add more outputs as like combo or data. And you see it's got added into the network or into the library. Next is this is like configuration of the driver. And you can configure endpoints which would look like basically lights, TVs, mini fridges, like different appliances within a building that can be configured. What you see up on the left, that drop-down menu, through that drop-down menu, they're able to specify the type of the cabling. And as you can see, as every device is being connected, the load is being calculated back to the switch or the driver it's connected to, and that builds up all the way back to the switch. And if you click like the tag, basically it shows you the tags on all these. Here I'm selecting those wires and I change them from Cat6 to basically 16 gauge wires. Here we're activating the controls. As you can see, we have like a wall switch device, and I can specify which driver or which lights this wall switch will be controlling. This connection and this control like function allows us to do post-construction servicing as well as commissioning. Here, for example, I'm putting like a test device that has a load bigger than the capacity of the system. And as you see, once I connect it, you get this red gauge, basically telling the designer, you've used a device that exceeds your load capacity on the driver and on the switch at the same time. Next, as you can see, each device right now has this exclamation mark on it. And what that tells me, it tells me that this device has not been yet married to a BIM family in my BIM model. So what I do, I select the device, I select this icon, so now it's telling me select the switch that you want it to be married to. Right now it got done and the exclamation mark is gone. And as you can see on our material list, you see that it's been associated. I'm doing the same thing with the driver now, and the exclamation mark is gone. I can see it on my material list that it's gone. And if I select it and zoom or click the search, it will zoom in the Revit to show me exactly where is that device is within my layout. Right. At the end, I'd like to thank Sinclair Digital for giving me the opportunity to work with them and learn their technology, to be able to work on such an innovative plugin that would bring a different approach to the design and modeling of FMP and PoE systems. I also would like to thank Technodyna, who's our software development arm. They basically made all our vision true, and everything we envisioned this plugin would function like, they made it possible. And that concludes our presentation today. If you guys have any questions, we'd be very happy to answer. All right, thank you.
Maybe I have a question.
Go ahead.
Well, it seems a very excellent design tool, and I think it brings more intelligence to models. And yeah, it will of course be a contributor. But I have a question, because the information that you create, it lives only in the plugin, or is it also pushed to the model that it can be extracted by other people?
It can be extracted into like your shop drawings. It can be extracted into your bill of materials. Basically, everything you do with a regular electrical or mechanical system that you model on Revit, you can extract that system in the same manner to the same extent.
Okay, so it does capture all of the design philosophy, and also in facility or maintenance and such, it could be useful to reuse that.
Correct.
Afterwards.
And once the cable routing is done, you have a fully functional BIM model that shows your cable routing, and that cable routing will specify which cables are running through it. And you will be able to produce an NWC file that you can then use on Navisworks in clash detection and coordination with other trades.
Okay, great. Yeah, I'd rather have IFC, but NWC is a good start.
Good.
Thank you.
Thank you very much. All right. Thank you very much, everyone.